For those of you guys that are checking this out later, Mariah and Jacqueline, I am going to assign this to you guys. It's going to look a little different. Actually, this one did not pop up. I think it's going to say pre-cal graph analysis review makeup. And so that's going to be like a quizzes you can take on your own without having to take it with us. So that's going to be in your Google Classroom. So take that first, pause this video, and then come back and hear us go over the quizzes activity. Domain. Question, why are there brackets?
Oh, because
the circles are not what? Open, they're closed. Yeah, so if they were open, they'd be parentheses. In calculus, almost every interval is in parentheses, almost everyone, because we're talking about what's happening between. But for this one, we just get to look at the graph and say, where does it start and where does it stop? But wait, domain, are those x's, so left, rights, or are those ranges, y's, so up, downs? Left, rights, right? Yeah. So left would be -5, right would be 5, and that's why that second -5 to 5 was the right answer. It was how left, how right. Decreasing, what are we looking for? Where it's going? Down, because we just get to look at the graph. Where is the function? Look, it's the function. It's going down on the other side, right? But in calculus, what do we say about when it's going down? What's also true? What are the tangent lines? How are they sloped? All those tangent lines on any portion of a graph where the graph is decreasing, those tangent lines are? Say it louder. Negative, yeah, those tangent lines are negative. And what are the tangent lines where it might be going up? Positive. Positive tangent lines indicate upward movement. Negative tangent lines indicate downward movement. But anyway, where was it going down? We look at the x values. Some of you might have been looking at the y. Look at the x. We discuss graphs based on x intervals. So from 2 to infinity. Ew, I did not like how they wrote that, but oh well, we'll just take it. It's from 2 to infinity. There should not have been or equal to's anywhere, right? There should have been parentheses. Don't love how they wrote it, but still from 2 to infinity was the proper one. Ooh, ooh, anybody miss this one? Oh, most of you got it right. Interesting. What did it mean by positive? The function positive, not the derivatives, but the function. Where it's what? Actually, no, it's not where it's going up. A positive derivative, no. There's something that you're thinking. A positive derivative indicates the function's going up, increasing, right? But if the function itself, where is this positive? Where are the values? Not the slopes, which would be like that, but where are the values positive? What are we looking for? Positive y's, and positive y's, you're not in the ground, you're in the sky. What does that mean? You're above the what? X-axis. Yeah, so where is it above the x-axis? A lot of you guys got it right, but I'm not sure you knew why. It's above from -4 to 0. It's above from -4 to 0. So if we're thinking about the positivity of a graph, remember graph analysis. Positivity of a graph, where is it above? If it asks negative, what would I be looking for? Where it is below. And if I was asking for the zeros, that's when it's on, right? Negatives down here, positives up here, zeros right there. Super important, the difference between a positive value and a positive slope. Okay, x-intercepts. Oh, easy cheesy. Did we all get them right? Mostly. X-intercepts, where does it hit the x? At 0 and 4, right? If we come down here and look for another increasing interval, where is it going up? It's only going up in this one region, but once again, a few of you might have gotten it incorrect because you should have been looking at the x's. Maybe you were looking at the y's. Where does it start? At x equals -1. Where does it end? X equals 1. That's that region. Should be open because it's in between. So from -1 to 1 was the proper. We're not writing points, we're writing beginnings and endings. What's that word from pre-cal? I've used it a couple times. If I have like beginning and ending symbols and a comma, but I'm talking about all the numbers in between. It's not an x, y. It's not an ordered pair. That's not what these mean, right? What are these guys? Intervals. Good. Intervals. Beginnings and endings, right? Okay, this one's bad, right? Why was this one bad? I don't know, but let's talk about it. What's the right answer and why? Okay, so you can see the right answer. But what's the question asking? Why is it -2 to infinity? Why is that the range? Again, the whys are how high it goes, but that's the second one, right? How high does it go? It goes to infinity. But the first one is how low it goes. How low does it go? -2, right? How low does it go? -2. So remember, range, silly way of remembering it, but rangey is the cute little R-A-N-G-E-Y. It's the cute little rangey, looking for the y's, looking for the how high, how low does it go? Rangey. Domain X, domain goes with the x's. Okay, that one was a bit rough. Keep going. Ooh, this one's pretty good. Domain and range. Domain. This. Hey guys, what basic graph is this? Close. ln is the really, really slow one, but exponential, it's inverse. Just think of your motivational speakers or somebody trying to talk about, I don't even know, how fast our world is falling apart. I don't know. Exponentially, to the nth degree. Lots of speakers like to use those types of things. If we have to the degree, if we have to the variable power, anything exponential has this swoop, unless it's been reflected or something. But yeah, exponential like an e to the x or a 2 to the x or a... This one's technically 2 to the x. How do I know that? Because 2 to the 0 is 1, and 2 to the 1 is 2, and 2 to the 2 is 4. That's 2 to the x. Anyway, exponential, it goes forever left, forever right, which is why the domains are all real numbers, which most of these are. But range, how low does it go? How low does it go? 9 of you got it right. How low does it go? Yeah. Does it ever hit 0? No. Because that is, what's those things called? You get closer, 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 closer. But Lord of the Rings, you shall not pass. Asymptote? Asymptote? But what kind of asymptote if it's going this way? Horizontal asymptote. And hey, in calculus, what solves for the horizontal asymptote? Oh, come on, you know what I'm writing. ln. Oh, okay, I see it. No, you're right, I did that in pre-cal with ln. The limit as, how do I find horizontal asymptotes? The limit does exist. This is the ironic part. The limit does exist. But the x is going where? X, yeah, right? Negative. Something's going to 0. It's actually the limit that's, the other classes need that. The limit's going to equal 0. I'm getting closer and closer and closer to 0. My function is getting closer and closer and closer and closer and closer to 0 as x goes what direction? Negative infinity. I find horizontal asymptotes by taking limits to infinity, and we use degree tests to solve those. Or in this one, we would just have to know an e to the x gets smaller, smaller, smaller from our basic graphs, forever card number 1. Basic graphs. Isn't that number 1? Is that number 2? That's number 2. Number 1 is the unit circle. My bad. What do we have? Ooh, did you guys see your local max and your local min and your local max? Right? Did we have some absolutes? Sure. Did it mention absolutes? No. So I say, okay, cool. I have 2 maxes, local maxes, and 1 min. Hence why the answer was what it was. This guy, ooh, it's a little rough. Why is it a function? Yeah, it passes the vertical line test, but the question is, hold on, is there going to be a derivative issue? Yeah, because there's a sharp point. There's good. So I'm going to have, actually, hey, cool kids, what would the derivative look like for this? We do need to somehow take this pre-cal stuff and connect it to calculus. If the slope of this guy is up 1, oh, that's not pretty. I'm gonna, yeah, I know it's gonna be ugly. I'm just gonna say m is equal to, I don't know, up 1, It's not even a half. Well, maybe 1.5. So up 1.5 over 1.5. Okay, we could say that. Up 1.5 and then over 1.5. Sure. The slope is 1. Rise over run, up 1.5 over 1.5. But then this guy's slope is up 1 and over 1, 2, 3, 4.5. If I was to graph my derivative is the slope. So I would have to graph my little derivative at like, let's see, 1, 1, 1, 1, 1, 1, 1. This guy would be, oh, struggle bus. This is not scaled very well. 1, 1, 1, 1, and 1 over 4.5 would be something way down here, almost 0-ish. But it's going to be broken at the, oh no, my bad, sharp point. The slope only happens up until there. That slope of 1. 1, 1, 1, 1, 1, 1, the derivative is 1, 1, 1, 1, and then it switches to this little guy who's down here. Right here it's going to be broken. Right? There's disagreement. The derivative is a limit, so therefore my derivative function f prime of x is like, I'm 1. Ah, I'm 1 over 4.5. What? And there's this huge disagreement. And the brokenness, that's why the derivative doesn't exist, but my function's fine. My function's fine. It passes the horizontal line test. Okay. Let's get out of that one, and we're almost done. Where are we at? Oh, hey, that's just a plug and chug. That's just a plug and chug, right? It's a quick reminder for anybody who might have missed that one, just because this one is basic review, but still some of us might get confused at h of 4. Remember, of just means plug it in, and what do I need to remember when simplifying this? That's way harder for algebra and pre-cal kids usually. What order do I go? Left to right, usually, and I have to look at, starts with a P and ends with a MDOS. PEMDAS, I have to do my exponent first, and 4 times 4 times 4. Maybe the mental math went a little wonky. And then I do multiplication, and then I do put it together, right? Okay, pre-cal review. Why did we do all of that? Well, what's going on in section 3.5? What do you see up there on the top? Where do we get to start? Pre-cal. Doesn't mean that you got 100% on that quiz you just took. Some of you guys were going for speed. Some of you guys were doing mental math. Some of you guys needed to review things like domain and range and intercepts. Horizontal asymptotes. How to write things to express what you see. But take a second and revel in the fact that we get to start the semester off with not all of pre-cal. Think of what your worst topic was in pre-cal. Shout it out. What was like the worst thing you remember from last year? Anything, the entire year in pre-cal. Is there anything you particularly hated? Huh? No. Oh, yeah. Sorry, I know. All of last year is. Can you think back to like pre-cal and the tests and the sections? Maybe it's just a blur.
Oh, the complex fractions.
Complex fractions, those could have been messy. Andy, what were you saying?
Yeah. Didn't we have those like systems of equations?
Yeah, those big old nasty like row reduced echelon forms, and then we went to matrices and all of that crazy. Yeah, so the row reduced. Man, no one said the one I expected. Starts with a V and ends with a
Vertices.
O. No. Despicable Me.
Vector.
That's what I expected, but I know COVID has you right. You're like, I don't know. All I remember from last year is okay. All of those things you just said are not the pre-cal we're doing. All of those things you just said, that's not the pre-cal we're doing. So take a deep breath and be like, whew, all right, we're doing the basics of graphs, and you just reviewed them on quizzes, most of them. Okay? So here's the dealio. Could I just go through and reteach to you guys all what the intercepts and the asymptotes and everything? Yeah, sure, but I don't want to do that. So instead, what do I have up here that I'm going to use the whole time? Do you see him? Do you see my little baby example function? The difference between the quizzes that you just took and what we're about to go into and why we're doing this in calculus is what you just took, most of the graphs were given to you. Does that make sense? Like you were able to look at the function and say, oh look, it's going up, it's going down, it's going up. Haha, I can look at it and see. But what we're trying to build is the skill of being able to see the same things, but in equations, not just in graphs. Someone help hold on now. Okay, here we go. Let's go fast. Fast but not too fast. Fast but not too fast. X-intercept, you set the y equal to 0, right, cool kids? So take the example function. Do you have it written down? Maybe get a different color pen because then your notes will look nice because you'll have like the actual reminders of what to do along with the, oh hey, and here's us actually doing it. Oban, if you're ready and this is easy, just fill in the stuff for me and you can check your answers and make sure you're right. Here we go. Set y equal to 0. So 0 is equal to 2x. Quick reminder from algebra, cool kids, how do we solve that for x? Just shout out what you're thinking. What's a step that we can take? Nah, we already plugged in. Y is equal to 0. So now we got to get x by itself. There's yucky division. Whenever there's yucky division, what should we probably do?
Would you switch the x and the y?
Nope, that's called an inverse. That's if we're doing a limit. Go back to algebra. Go back to algebra. 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 How do I get x alone? I could try to factor, except question. What happens if you guys are doing all the hard stuff and you're forgetting the easy stuff? If there's division, shouldn't I just move it to the other side? But 0 times anything is 0 times anything is 0. So question. Yeah, if 0, I know. You're trying to make things way too hard. X is just equal to divide by 2. I don't know why. X is equal to 0, right? Divide both sides by 2. Do you see why we're going back to the basics? Okay. If x is 0, 0 divided by any non-zero is going to give me 0. So if I want the whole thing to be 0, the numerator being 0 is exactly what I want. So here's a quick little reminder of what we use in calculus for critical numbers and pips, but technically could have been a strategy in pre-cal, and I think I showed it. That doesn't mean you remembered it. The pitchfork. What is the pitchfork? The pitchfork is saying we're trying to talk about the zeros of the numerators and denominators of functions. I'm going to put n for numerator, d for denominator. This isn't necessarily a derivative or a second derivative. Just in general, this is pre-cal page, right? Pre-cal page. What happens when you set the numerator equal to 0? You get the zeros. If you set the numerator equal to 0, let me just show that. Whatever you have, an f prime, an f double prime, the numerator equal to 0 is going to get me the zeros. Sorry, my this implies arrow looks not like a this implies arrow. There we go. Whenever I set the numerator equal to 0. So a shortcut could just be 2x equals 0, x is 0. Perfect. But some of you need to see the algebra, like whatever, multiply it to the other side, it's gone. Poof. But what happens when I set the denominator equal to 0? I can divide into one piece. You don't do anything. I can divide into 2 pieces. Awesome. Cut it in half. I can divide into 3 pieces. But how can I divide an actual something into 0 pieces? Have you guys ever thought about what division by 0 really means? Pick some object in the room that I could like cut. Here, if I had a saw, right? Josh. No magic tricks today. If I was to have this, and if I had a saw, could I cut this into 1 piece? Well, I could. It would just be the same, right? Dividing by 1, it just stays the same. Yeah? Cool. Could I cut it in 2? Yeah, just, right? Could I cut it into 4? Easily. After that, 3, okay, awkward, right?
Yeah.
How do I cut this that I'm holding into 0 pieces? I can't. Because it's still here. What do you mean 0 pieces? It's automatically 1. Now let's not go into negatives right now because it's a little dicey. But can I divide by 0? No. So what happens when I divide by 0? What happens when I have zeros in the bottom? Those are going to be my undefined points, also known as discontinuities, right? Tops give me zeros, bottoms give me undefineds, if I'm talking about 0. Okay. Y-intercept, Josh. Do you remember what you said that I said no? We already did that. Sort of the P and ended with a lug-in.
Yeah.
So we're going to take this little x equals 0, and what are we going to do? Oh, we like this one. It's the easy one. Y is equal to 2 times 0 all over. Wait a minute. If the top is 0 and the bottom's not, isn't 0 divided by anything to 0? Oh, 0, 0 hits both axes. Okay, cool. Right? Doesn't 0, 0 hit both axes? All right. Question, do we have any non-removable discontinuities? What does VA stand for? Vertical asymptotes. Where are we looking for those? Denominator. What are the zeros of the denominator?
Plus or minus 1.
Didn't somebody a little bit ago, I know who you are, I just don't want you to call you out because you might not remember, mention factoring at the very beginning? That was one of those, I don't know, factor, I don't know, do this, I don't know, do that. And you guys missed the easiest part, just multiply. Now factor. Why? How many different vertical asymptotes do I have? 2, because I have one for a positive one. Actually, that'd be a negative one. And one for a negative one and one for a positive one. I have both zeros possible. Or both as zeros of the denominator. So what is my vertical asymptotes? I have VAs at x equals plus or minus 1. What do I have so far at the point 0, 0? Kind of anticlimactic because it's the same for both. I have x equals plus or minus 1. Wait a minute. Are there 2 different types of discontinuities? We just took the zeros of the denominator and we said, sure, those are vertical asymptotes. So hold on. Where would holes come from? What's the difference between these 2?
One would make it 0 and then denominator.
Keep going.
Oh, yeah. Okay, hold on. Hezzy's remembering. 1 would make it, you said 0 over 0, right? 1 would be a 0 of the top and bottom at the same time. That's removable. You could factor it out. Or limits, you could keep going. Remember L'Hopital is the very end of the semester. 0 over 0. The function does not exist, but there might still be an approach that exists. There might still be a limit. That's a hole. Do you remember what vertical asymptotes look like when I plug in? Aren't they number over zeros? What am I talking about? Is 1 and negative 1 a 0 of the top and the bottom? No. The 0 of the top we already figured out. For our function, the 0 of the top, 2x equals 0, is just 0. Bing. Bing, bada, boom. Where's it go? Up here. It's the 0, y equals 0, the function equals 0, at 0. It's the 0 of the function. This guy, x squared minus 1, we've got x equals plus or minus 1. The question for holes, are there any shared? No. Since there aren't any shared, are there any holes? The answer is no. So sometimes in this whole like 14 identifies thing that we're kind of building right now, you just think we're doing pre-cal, but we're doing it for a purpose of analyzing that function, the equation, fully. One way of seeing it is this plus or minus 1 would not make the numerator 0, so no, it's not a 0 of the top and the bottom. It's not a hole. Another way of looking at it is, if I was to factor this all the way out, question, could I reduce anything? Let me write it. Hold on. Can I reduce anything? Does anything match on the top and the bottom? No. No reducing, no removing, no holes. Hey, somebody said degree tests. That's great, but you were way too early. Degree tests. Degree tests are for limits to negative or positive infinity. There are algebraic ways of doing it. Hovan and I talked about multiplying the top and bottom by 1 over. There's something snazzy that online or WebAssign might show. That's good, but we simplify it with degree tests. Degree tests say, look at your function, take a limit as you go to infinity or negative infinity, and ask yourself which one wins, top or bottom. And if the bottom wins, what do we say? Yeah. If the bottom wins, it's getting closer and closer and closer to 0 to the infinities. If the bottom wins both directions, which with algebraic stuff, with polynomial stuff, not necessarily e's or sines or ln's, but just basic algebraic numerators and denominators with x's, yeah. The bottom, if it wins one way, it'll win the other way. The bottom wins, my entire function is going to 0, so I have a horizontal asymptote at 0. I have vertical asymptotes, I have horizontal asymptotes, I only have 1 point, kind of lame. Oblique asymptotes, if there is one of these, it negates one of these. Oblique asymptotes, if you have a horizontal, it won't have an oblique. An oblique is a slanty guy. If you have a flat guy, you won't have a slanty guy also. And behavior, it's not going to be going 2 different ways in the same direction. But what this says is if it was to have an oblique, what we would do is we would put that numerator in long division. Do you remember? Pop the numerator in the box. Put the denominator on the outside. You would say, how many times do you go in? But question, guys, does x squared go into 2x? No, that's bigger, that's smaller. I can't multiply anything. I can multiply it by 1 over x, but we're not going to go there. If that can't divide in, forget it, none. If it could divide in, we'd have an oblique guy. Symmetry, oh, even odd, it was in your summer packet. Symmetry, even odd, it was in your summer packet. Even odd, we would say, hey, let's plug in f of negative x and see what happens. And so in our function, we would have 2 times all over. We would plug in negative x's all those places. Negative x, negative x. What happens when you simplify? Does it stay the same? Is it the opposite, or is it neither? What happens on the bottom with the negative squared? Uh-huh. You guys agree if you were to simplify that? Simplify that puppy in the denominator. X squared minus 1, that stays the same. Ooh, but what about that numerator? Yeah. So if you have a negative, that technically, like WebAssign or something, or Calc Chat might pull that out to the very front. That's opposite. If it's opposite, isn't this an odd function? Origin symmetry? That guy, opposite, he's odd. Another reminder, opposite, odd, odd means origin symmetry. So somehow you can make my graph have origin symmetry. And last but not least, my domain is going to be negative infinity to negative 1, negative 1 to 1. If I was thinking intervals, 1 to infinity, that's my domain. Remember, not 1 or negative 1. So negative infinity to negative 1, stop. Start again. Negative 1 to 1, stop. Start again. 1 to infinity. I have to avoid my vertical asymptotes. Whew! Putting the pen down. You guys, when you get to the end, throw your pencil down, take a deep breath, and look over those categories and see if any of those categories you want me to kind of talk on any deeper. We're about to go to calculus. I'm missing an eraser. There's no other eraser. You get to delay the calculus if you think of a question you want to ask on any of the pre-cal on the screen. Okay, pause, take a second. Your notes are hopefully cleaner than mine because I have to squish all mine in on this nice little Jamboard. But can you go back and can you underline each of the categories that would help you in analyzing a graph? Can you underline x-intercept? Can you underline y-intercept? Make sure that your brain sees the categories. We did the example, but that wasn't teaching it, right? A lot of you just stayed in pencil. So if you stayed in pencil, it's probably a good idea to make sure that you somehow show yourselves what are those, without the graph, what are those pre-cal things that we can analyze? Intercepts, asymptotes, poles, all the different asymptotes, symmetry and domain. What's missing? Making a big old table and plugging in lots of points and hoping we have enough to see what it looks like. But that's the dangerous part. We could do it, but that's not very precise, not very systematic, and dangerous. And I would say probably this whole technique of what's the difference between zeros and undefined might be helpful also. And depending on your notes, if it would be helpful, mine is just going to look worse, I think. But you could also do a quick, if you just stayed in one color, you could do a quick little like marking. I wouldn't underline, but maybe like a highlighting of those little pre-cal tips or tricks that I put along the way as far as notes. That's only if you didn't change the colors up. All right, I'm going to count down from 5. Let me know if you need any clarification that you know of right now on the screen. What's it time for? What's it time for? Whew, the calculus stuff. What's it time for? The calculus stuff. Now, I've gone ahead and separated because it's going to get too messy. These are my quick little reminders. I'm going to do my example over here. Does that make sense? So why don't you take a second, without me talking, and why don't you just get your quick little reminders of what I'm about to do in each of these sections. Is that okay? Quick little reminders of how to do critical numbers. Quick little reminders of what we do with increasing, decreasing. And then I'll use it to do the example. And if you guys haven't noticed, hold on, pause. I have solved and simplified, like those little cheater pages in those homeworks at the end of last semester. I have solved and simplified the first and second derivatives so we can just use it, okay? I've already done that. That's just for the example. The yellow box is the calculus reminders. We get to rest. You get to not listen to my voice. And review quite a few forever cards. People online, I'm going to stop the recording just to make it a little bit shorter if you guys want to pause and write this down also. The recording will pick up when we start solving. Critical numbers, zeros and DNEs. We already talked about the pitchfork, so the nice thing is, all we got to do is take this little guy over here. The negative is technically inconsequential, but I can show you why. For critical numbers, we can set the numerator, so -2 equal to 0, as well as, you only need the negative in one spot. If I was to do the algebra on each of these, let me do it with my laser pointer if that's okay to save on space. I would go ahead and divide both of these, dividing by that -2. Dividing by that -2, 0 divided by anything is 0. I would just end up with this guy equal to 0, which would lead me to an imaginary number. would lead me to x is equal to plus or minus the square root of -1, which would not show up on any of my real graphs. So I can ignore the imaginary, it's not going to be there. The denominator, if I was to solve, I would square root both sides to get rid of that squared. So I would really just have this guy equal to 0 with some factoring like we did similarly when we had this expression before. I would go ahead and get x is equal to plus or minus 1, but in context, what did we just say plus or minus 1 was in the pre-calc? Check it. What did we just say plus or minus 1 was? Yeah, they're undefined. So technically, I am going to throw this little guy, I'm going to throw a not equal to. I technically have no critical numbers, but only because the only crits I find are vertical asymptotes. But when I come to do my first derivative sign chart, maybe quick reminders for this might be helpful. This is the calculus though, so I'll do it in blue, not green, but these ones are my horizontal tangent lines, whereas these ones are my vertical tangent lines, or sharp points. Just if you want to like clarify what's what. They were possible sharp points, but since they're vertical asymptotes, oh, never mind, they're nothing. Or they were possible vertical tangent lines, but since they're asymptotes, they can't be points on the graph. But I'm still going to put them in my sign chart. So a quick little reminder of my sign chart is I'm putting in crits and let me just do discontinuities. I was going to say domain restrictions, but I can just say discontinuities. I think domain and I think crits when I'm making my sign chart. So, sign chart. The domain is from -infinity to infinity. But whether you're looking at domain or whether you're looking at your possible crits, I need to think of -1 and 1. I'm going to put little empty circles, not because they're holes, but because they don't actually exist. That reminds my brain those are discontinuities. And now I'm going to test for my signs of my first derivative. Oh, how do we test for signs? Do you remember? How many points do we need for each interval to test? Just one. Because we split up our intervals, the behavior can only change at a crit. Only at one of those leveling off, like you saw in some of those graphs in the pre-cal quizzes, or at a sharp point, or at an asymptote. So I just need to test one. Something like -2, I could test that. Something like 0, that's an easy one. Something like 2, you can pick -10, 0, 10. You can pick -100, 0.75, and 3.67. I'm just trying to choose easy things. So -2, 0, 2. Coming back here to the first derivative and plugging and chugging. Maybe mental mathers, you could help out. Top's going to be a positive times a negative all over. Oh, anything squared is always going to be a positive. Yeah. That's a negative. And then 0, well, it's still going to be a positive and a positive because it's squared and then times a negative. Wait, that's going to be a negative. And then 2, that's going to, oh, that's weird. This thing is just always decreasing. Huh. Always decreasing because remember the sign of the derivative, the positive or negative of slope, indicates the behavior of the original in the sense of decreasing, decreasing, decreasing. So extrema, do I have any relative maxes or relative mins? Nope. A, I don't have any critical numbers because they're just asymptotes. And B, there is no, and even if there were points, there's no sign change. There's no behavior change. So there's no dipping and there's no peaking. No mins, no maxes. Pips. Say do the same exact thing, but you're pitchforking this time the second derivative. So like I said, I already have that up and over here to the side. I'm going to change the color just for the sake of, yeah, I'll go to yellow, I guess. Just for the sake of distinguishing what we're doing, all of this was leading up to relative extrema using critical numbers from the first derivative. Always have to use first derivative zeros or DNEs to be relative mins and maxes. Pips, say look at the other guy. So the other guy would be set the numerator equal to 0, which would technically lead me to x equals 0 and x equals plus or minus square root of -3, which once again is an imaginary number. Imaginary numbers won't show up in my graph. Remember from algebra, you would set each one equal to 0. In my Algebra 1 class I'm teaching this year, it'd be like Moses, split the Red Sea. If there's multiplication, where's the multiplication? If it's there, I can split it up into whatever or however many factors I have. I had them get colors out, they colored them. Set each one equal to 0 to find the zeros. First one gets the 0, the second one gets the plus or minus square root of a negative, which doesn't exist. But I also have to look at that denominator, but if you guys notice, it's going to be the exact same issue as what we had before. I'm going to get the vertical asymptotes, which are great, but those can't be pips. They're not even points. Even though I would set the denominator also equal to 0. I'm not going to say the points don't exist. Plus or minus 1 are real numbers, but remember, those are my vertical asymptotes. So sure, I'm going to put them in my sign chart, but not because they're pips. They're not even points, because they're domain restrictions. Throwing in my sign chart. Throwing in my important points, which my pip I have as 0, and then my domain restrictions. Those are discontinuities. 0's fine. 0's actually a point. Hey, do you guys remember how I asked you at the very beginning of class, as soon as you did the quizzes, why the brackets? Do you remember what you answered? Why the brackets on the domain for that one picture? The circles were filled in. Yeah, remember filled in means yes, it's a point. Not filled in means no, it's not. That's all I'm saying. These guys are DNEs. That guy actually exists. And then, Victor, I think you were the one that was answering. How many points do I need to plug in to test the behavior? Just one in each interval, right? So I need one for the, over here on this side. So 1, 2, 3, 4. It's split into 4 intervals. Plugging in, I mean, I could do the -2. I just can't do 0 anymore. I can do like -0.5 and +0.5. So I have to be on either side of 0 because 0 is a pip splitting things up. Mental mathers, keep me honest, okay? We need to plug in and just check the sign. So a -2 would be a negative multiplied by 4, but that's a negative squared is positive. So I have a negative on top. Ooh, cubing. Hold on, that could be positive or negative. I might, just to keep myself honest, put the negative in the numerator. And then a -2 squared is 4. 4 minus 1 is a positive. Cubed is positive. Okay, so this first guy is negative. A negative divided by a positive is a negative. -1/2. Still a negative times a positive. So I still have that negative in the numerator, but hold on, -1/2 squared is 1/4. 1/4 minus 1 is a negative number. I'm doing this in my head. It's super dangerous. I'm doing it because I have to go fast. And because plugging in is something that's review from before. It was in the pre-calc quizzes, right? And I have all of you to double check me. I'm hoping someone would give a shout out and know that I would welcome that if I was wrong. So I'm pretty sure that's a plus. Let me know if I'm wrong. Plugging in a +1/2, a positive, but that little guy's still going to be negative because 1/4 minus 1 is a negative, cube stays negative. Positive over negative is a negative. And then plugging in 2, positive, 4 minus 1 is positive. If I was to think about behavior, I could say two different things. One thing is I could go to f prime and just go back one level and say, well, the derivative's going down, going up, going down, going up. From my first derivative test. No, my increasing, decreasing test. What does it take for something to be, for a quantity or a function to be increasing or decreasing, for its derivative to be negative or positive? I can say what the derivative is doing, but I can even go farther. I can go 2 steps back and say what the concavity is. I have concave down somehow, concave up somehow, concave down somehow, concave up somehow for my original function. I have all these changes in concavities. So how many points of inflection do I have? You would think 3, because it's like it changes, it changes, it changes. And all I need for a point of inflection is for the concavity to change. False. And the point to exist. Where are there not points? That's an asymptote. That's an asymptote. These are not points of inflection because these are not points. What's the only one that's a point? Booyah. He's my only point of inflection. He's my only point of inflection. Am I showing an interval right now, or am I showing an ordered pair? Can anybody read my mind? Because it says what? Find the point. So how do I fill in the y value of the point on my original graph? Am I plugging it into f double prime, f single prime, or f? If I need the point on the graph. I don't want a slope. I'm not plugging it in the derivative. I don't want a slope. I don't want a steepness. I don't want a slope of a slope or a rate of a rate. I just want the original value, so I'm plugging it into the original function. Which, has anybody lost sight of the original? Where is it? It's way back here somewhere. Where's the original? Here it is. Oh, what happened when I plug in 0? What did I get? 0, 0. Okay, how do I take all of that analysis? How do I take all of that analysis and how do I graph it? Okay? Start with the pre-cal. Someone tell me something. What's something that we know from pre-cal? Plug it in, plug it in. We plugged in 0 and we got out what? So we have our x and y intercepts at 0. Cool. What else do we know from pre-cal? Just go through the list. What else did we write down? What was happening at -1 and 1?
Oh, vertical.
Okay, so I can put vertical asymptotes from pre-cal. And then I'm going to have a graph here from negative infinity to -1, a graph here from -1 to 1, a graph here from 1 to infinity. What else? Ooh, horizontal asymptote. That's 0, right? So eventually my graph needs to level off to 0 that way and level off to the axis that way. That's all that pre-cal could give me unless I go making a table and plugging in lots of random points, which we did last year. Sufficient points, but go to calculus. Tell me what else you know. Tell me what else you know. Yeah, okay, cool. So what's the concavity over here from negative infinity to -1? Careful, the second derivative is negative, which means the concavity is concave down. Is that right? Cool. And what do we know about increasing, decreasing? Do we know anything about that? Go look at the increasing, decreasing chart. What's happening from negative infinity to -1? We already got the concave down. What was the increasing, decreasing? I think it's down, isn't it? All over here. So it's decreasing and concave down. So it has to only be decreasing and concave down. So doesn't it make sense it's going to be doing something like this? And I know it can't pass the axis or else it would have been a 0. Okay, has to get closer and closer to 0, has to be concave down, has to be decreasing. Could I plug in some points to make it perfect? Sure, but I just want the behavior of it. I got it. What do you guys know about -1 to 0? It's concave up and, sorry, what was it? Increasing, decreasing? Concave up and, oh, it's in this decreasing. Oh, everything's decreasing. Oh, yeah, that's right. So it's decreasing and concave up, but what changes at 0? It's still decreasing, but now it's concave down. And I need to get closer and closer to my asymptote. If it's concave up, it must be going like that, and if it's concave down, oh. See it? It's always going down, but it was concave up to this side of the point. I knew it had to go through there. Concave down, there's my point of inflection. And then like an x cubed. I mean, we don't see that here, but similar behavior. Then over here, as we already said, it's always decreasing. Guys, it changes to concave up again, right? How could you be decreasing, getting closer and closer to 0, and be concave up? If you graph it in your calculator, guess what it's going to look like? And it's not me guessing with random points, it's me knowing based on the calculus behavior. So what's all of section 3.5? Stuff that you could maybe answer if you just graph it on your calculator, but is that the point? No. The point is, what can you figure out from the calculus? And as you're figuring these things out, you're solidifying all those forever cards from chapter 3A. 3.1, 3.2, 3.3, 3.4, all of this stuff you're solidifying and practicing. So what else if we had like infinite amount of time? What would we keep doing for all of class? Practice, practice, practice. Okay? So I'm just going to go ahead and run through a few things that could be a little sticky, a little dicey. What I actually have, I think, on Google Classroom for you guys, let's go over there and check out Google Classroom real quick. Yeah, here, let me zoom in so you guys can see it, just in case the words are a little too small. The video below and or the recordings from the last few years provide the lesson and all the examples. I'm not getting through every single example, but if you guys notice, what examples do I have in those videos? I have a good old-fashioned nasty polynomial. I also have some sort of weird multiplication of like a radical and a non-radical. And if you guys notice, I also have like their derivatives that you could practice with, or you could watch me do, like, what if this is happening? How does this all look and where do I land? And I guess those are the only ones. Then this is like just stuff I'm going to go over in just a second. But I have a lot of examples if you get to a type of function that's funny. Where could stuff get hard? Yeah, like what could show up that would make things tricky? The pre-cal, which is kind of like that 4th degree we just saw. The pre-cal could get hard if you have some sort of big polynomial, which is ironic. You're like, the pre-cal's not hard. Oh yeah, it is. For y-intercept, it's easy, because for y-intercept, we just plug in when x is equal to 0. Cubing 0 minus 3 times 0 squared, that's easy. Right? You end up with y equals 3. I have the point 0, 3. That's not bad. What's bad is, how could you find the 0 of this guy? But what's the problem? It's not even a quadratic, it's a cubic. Okay, so could there be a couple problems where the factoring would be gross? Yes. And so I'm just warning you, there could be some tricky pre-cal parts. Those pre-cal parts would say, okay, we might need to do like a synthetic division. I know. Here, hold on. Ready? I'm okay if you go to your graphing calculator for the tricky ones. Why? The AP will never give you a cubic that you need to factor. That's just not something we need to do. Is that something that's good to kind of know from pre-cal? Sure. If you want to challenge yourself, go for it. Sure. But I'm admitting this is a tricky pre-cal part. I'm letting you kind of shortcut. Go get the 0. Now, when you go get the 0, will you see the graph? Maybe. Maybe. But remember, we're getting practice in with kind of putting all of this together and realizing it all helps us analyze. Could I go back and review synthetic division? Sure. Do our brains want to do that? No, and it's okay. The AP won't ask that. So that's a tricky pre-cal thing. Another tricky pre-cal thing might be if I'm doing something similar. Once again, plugging in zeros, these ones are pretty easy. It's not so much the plugging in 0 for the y-intercepts, it's setting it equal to 0. These ones are not calculator ones. You can do it, your brain just might not like it. So can I kind of use what I did with my algebra kids and show you Moses splitting the Red Sea? Well, okay, if you guys want to see why I say that. I do all the multiplication. Like, where's the multiplication? I show it in red. It's like, hey, as long as we have it factored, as long as there's multiplication, you can split it. And then I use different colors, to be honest. And say, okay, there's, ooh, wrong one. There's one factor. Here's another factor. It's legal. Split it. I know there's a square root, but whatever. Split it. You're fine. So you would say x equals 0 and the square root of 9 minus x squared equals 0. I can square both sides. No big deal. 0 squared is 0. I can either factor 3 plus x, 3 minus x, and go from there, or add the x squared and plus or minus square root of 9. Just reminding you. You can do it, even though it looks funny. Why would this one be a little bit rough? Well, there's no multiplication, it's addition. So there are a few different ways of doing it. Probably the simplest way, and thinking of like critical numbers and we want a nice fraction, probably the most straightforward way would be to go ahead and get that x squared plus 1 common denominator. You usually want to get it to be a single fraction just for simplicity's sake. And then we would have x cubed plus x. So the common denominator is messy. And if I'm looking for zeros, remember the zeros would be coming from that numerator. That numerator is just like this guy with the cubic. Okay. If you want the zeros, go ahead. Remember I said you could skip this and you could take this to the calc to find those intercepts. If you get to cubics or quartics, it's okay. If you can't pull out like a GCF and make it a quadratic, that's okay. How can the calculus get tricky? Noah, Victor, somebody said that the trig could come, right? So yeah, what if trig comes? Now, A, before this, you guys already know from before the semester ended, critical numbers, taking derivatives would get messy. But remember, I have in here some examples of, like, okay, there was a radical. Can you take the derivative? Yes. You just want it simplified. It takes some work. But that's not new. That's review from last semester. But what if you have a trig guy? His derivative's easy. The problem is, how do you find his crits? Pitchfork? Like, I want the zeros, I want the DNEs. I mean, I could think about this guy as 2 minus 1 over cosine squared, right? So then the DNEs would be cosines zeros. What would the zeros be? The zeros, I need the zero of the whole thing. So you could get common denominators. That'd be one way. I'm doing a calc chat jump. Maybe a WebAssign jump, depending on what they show you when you do the watch-its. DNEs, I need to think about him as him to get the DNEs. Cosine is 0 at pi over 2. Oh, it's already excluding that. And it'd be 0 again at negative pi over 2. Oh, it's already excluding that. So I can already think of my zeros of my, I mean there's more, but they're just having me spotlight this part. I already have those in my domain restriction, so technically I don't have to think about those as critical numbers. They're already going to be in my number line when I go to do my sign chart. I'm only looking in between, that's it. For the zeros though, well, I would need to go ahead and set this guy equal to 0, which will end up with getting cosine by itself. Add the 1, divide the 2, plus or minus square root. make it look pretty, you're going to end up with plus or minus root 2 over 2. Hey, is that a unit circle thing? Doesn't that happen at pi over 4? And negative pi over 4? Right? So there is something to be said for trig getting tricky. Not just because it's trig. I want to write those numbers below it, sorry. Not just because it's trig, but because there might be some unit circle stuff that comes in, which would be really hard to do in your calculator because remember your WebAssign won't want decimal answers if they're unit circle values. And then if I go to make my sign chart, it's going to be a little bit messy, as in you might need to be thinking of things like, hey, what is cosine in this part of the fourth quadrant? What is cosine in this part of the first quadrant? What is cosine in the part of this quadrant? As you're trying to plug into your derivative that's right up here. Josh, sorry, you had a hand up.
Oh no, I just messed up memory. I got that.
It was originally square root of 1/2.
Yeah.
But if you make 1 over root 2 and then rationalize it. I just tried to put it in the form that would be most recognizable. Yeah. But then we'd have to be thinking of something like, for our testing, what do we have, 3 intervals? Nice thing is 0 is right in between that one, so that's going to be an easy one to plug in. But you would need like a negative pi over 3 to actually get in between that guy, or a pi over 3 to get in between that guy. It's possible. You just have to kind of like think unit circle. So, what do we do today? This section, to be honest, guys, I could take like a full week and a half just on this section. The AP never makes you start from beginning to end of a function and totally analyze it. But what it does is it's like, hey, what about this characteristic? Oh, what about this characteristic? Oh, what about that characteristic? And you have no idea what they're going to ask you about. What's most important is that you know how to do this breakdown. Not entirely of every function possible out there, but you could jump to any place and be able to do what's asked in a question. Point of inflection, increasing, decreasing, concave up, concave down. The point is, can you learn all of these characteristics and ways of analyzing functions to be able to just jump in and out and do like a little piece here and there? So I don't want this section to last tons of time because we have other new things to learn, which is why I'm like, hey, let me show you the big idea with one rational function. Reviewing pre-cal, because it's always good to have a basic idea of what you know from the very beginning. And then practice deriving a bit, but you guys know there are those online derivative calculators that could get the nice simplified form for you. I want you to practice, if you know the derivative, can you pop in and out and make the right connections? And every now and then, if stuff gets weird or tricky, for things like factoring, or things like common denominators, maybe even trig to some extent. Just remember you're popping back to your unit circle, but there are some times when it is okay to look to your calculator because that is not the point. The point is not to review how to factor a cubic polynomial. So if you guys were to head to your Google Classroom, I do have this due Friday at 11:59. We're not spending all of class on it per se, but bring me some troubleshooting things if you need it, okay, from WebAssign. And then as you look over in WebAssign, it logged me out, bummer. Actually, that's a lie. I think I forgot to log in. I apologize. Just remember WebAssign is nice in a lot of ways because, ooh, is that the right homework number? Huh. Something's weird. I don't know why it's weird. But as you guys come over into homework, they're not necessarily going to force you to do this full process for every single problem out there, but check it. They are going to have you like, hey, intercepts, do you know those? Hey, relative extrema, can you do your first or second, your second derivative test would get you the points of inflection. Your first derivative would get you your relative extrema. Second derivative can also be used for that, but I wouldn't choose to take a second derivative if I can help it. I'm having you start off with a tutorial one, so it takes you step by step, and then it brings you to these. Now, the nice thing is of doing it on WebAssign, they're letting you match the graphs. You don't have to create them, which is a lot easier than the homework used to be when it was just you in the textbook. You get to fill in things, but just remember, when they're asking for these, they're asking for points. So you need x's and plug it into the original y's, but you're using your calculus to analyze. Does that kind of make sense? Kind of, sort of? And then one more time, do you have extra examples to come and watch me walk through, finding different bits and pieces if you need them? Right? Cool. All right, let's pause for today.